Okay, here we go, part 2. Part 2 here is actually practicing this stuff. Okay, and on these got it problems, I am going to explain the entire problem instead of me just showing an answer, because these are more complicated. So I'm going to go through all the got it problems. I'm going to start with problem 1 on page 500. So go ahead, pause the video, and what I will say is, before you pause, is if you end up with, you get an answer a certain way, and I end up doing it a different way, please watch what I do. Because my way just might be better. Well, of course it is. Just kidding. But it actually might be more efficient. Okay? But go ahead, try what you can. And I would stop after each one. Don't just do them all and then watch this whole video. Please do one at a time and pause the video. All right, go ahead, because I'm starting. All right, problem 1. What's the length of the hypotenuse of a 45, 45, 90? So I'm going to draw my 45, 45, 90 triangle. That's special. So instantly in my head, I know the side lengths are special. So I'm going to go ahead and, right when I see that, I would write out the relationships amongst the sides with x's, so I don't have to do it every time. And it was this, from what we had solved before in part 1. And now it told me the length of the leg was 5 root 3. 5 root 3. So this x value was worth 5 root 3. Okay? Which means in order to find the hypotenuse, I don't need to use the Pythagorean theorem because I have this relationship here amongst the sides in a special right triangle, 45, 45, 90. So I'm going to take this x value and I'm going to plug it in right here and just simplify it. So instead of x root 2 for the hypotenuse, I'm going to have, because x was worth 5 root 3 times root 2. And then I just have to simplify that. So I'd actually, neither of these are perfect, so I'm going to put those together under the root. So that would be 5 root 3 times 2, which is 6. And then I would go ahead and split the 6 back up if there was a perfect square I could find in 6, which there's not. So this is actually the length of the hypotenuse in simplified radical form. All right, going onward to problem 2. In got it problem number 2, you really only have to do part A, okay? Part B, I mean, I'll explain it, but you're pretty much doing it in part A. So in part A, the length of the hypotenuse of 45, 45, 90. So again, 45, 45, 90, x root 2. And then I'm going to redraw it as to what they tell me the information is. They say the length of the hypotenuse is 10. And what is the length of one leg? So in this case, I can see that my x root 2 is worth how much? 10. So I'm going to make that an equation. X root 2 is worth 10. So from there, I would solve for x, because x is what one of my legs is worth. So to get rid of a root 2 that's being multiplied, I'm going to divide by root 2. Root 2 divided by root 2 is 1, so those will cancel. And I'm going to do that to the other side. So the x value is 10 over root 2, which you could calculate out to be a decimal. But in your case, you need to practice just simplifying it as a root. Now, this is another feature of roots that you need to know. If a root is completely simplified and it's in fraction form, we should not have any roots on denominators of fractions. That's a rule. Meaning that we have to do what's called rationalizing this denominator. So we have to get that root 2 out of the denominator so it's considered mathematically simplified. So to get that root 2 to go away, watch what I'm going to do. I'm going to multiply the numerator and the denominator by a fraction that's equivalent to 1, and it's going to be root 2 over root 2. Because this is really worth 1. It's not going to change the value of this, but it's going to change the way it looks. So now when I go ahead and do that, on the numerator, I'm going to get 10 root 2, and on the denominator, if I put these together, is root 4. And what's nice about that, and this will happen every time, is that this will be perfect. Because if you notice, it's the same number being multiplied by one another. So the square root of 4 turns out to be 2, so I have 10 root 2 over 2. And I could simplify even more, because 10 divided by 2 is 5. So this becomes 5 root 2. So 10 divided by square root of 2 on your calculator should equal the same decimal version of 5 times root 2. But this is the answer that I'm going to show. So in 2 part B, why you'd multiply 6 root 2 by root 2 over root 2 is to rationalize it's called, the denominator, because that's a rule. When you simplify roots, you can't have any in the denominator. So going on to got it, problem 3. Go ahead, try that one. So you plan to build a path along one diagonal of 100 by 100, 100 by 100. So I'm noticing I'm going to get 90 degrees, which means I'm going to have 45, 45, 90, because I have 2 of the legs the same. And you're planning to build a, what are you building? Oh, a path. Oh, you're so nice. Across the garden. There's your path. And they want to know how long to the nearest foot that's going to be. So this is my x root 2. I always write that out for myself. So this side, if this is x, is going to be 100 root 2, but they want to the nearest foot. So I actually have to, on my calculator, take 100 times root 2, and I should get, I did this, 141.4213562, blah, blah, blah. If I go to the nearest foot, what are we thinking? 141 or 142? In this case, the 4 is going to leave it alone. So this is approximately 141 feet. Okay. Cruising along. Got it, problem number 4. And go ahead and pause the video, try it. What is the value of f in simplest radical form? So they give me a 60, 30, 90 triangle, which is a special right triangle. So for me, I like to think about problems and not resort to my notebook to look in it and have to reference it. So I try and redo it every time. So I start with an equilateral triangle, 60, 60, 60. And then what happens? Boom, cuts it in half. This becomes 30. That was 60. This was my length of 2x. If that gets cut in half, that's x. And we solved for this one earlier, and it was x root 3, right? So I have my reference over here of what I'm going to use. And they told me that the value here is 5, and I'm trying to find this. I'm trying to find the hypotenuse. So I noticed that this side is hooked with the 30, so I need the side that's hooked with the 30 over here that's adjacent to it, but not the hypotenuse, and that would be my x root 3. So this is worth x root 3. So I would need to solve for x to figure out the hypotenuse length. So I'm going to go ahead and solve for x here. So x root 3 equals 5, divide by root 3, divide by root 3. I'm going to have to rationalize the denominator. And I'm at 5 root 3 over root 9, which will end up just being 3. So my x is worth this, but I'm trying to find the hypotenuse length, which is 2 x's, so I need to double this. So 5 root 3 over 3 plus 5 root 3 over 3 is going to be, how many? Well, we have common denominators, so that'll be 3. And then I have 5 root 3's plus 5 root 3's. So how many root 3's? 10. So my f value, and is this simplified or do I need to rationalize? It's simplified because this is not a root. So we're good. And that's done. in simplified radical form. Whoa, that was a good problem. It really was, truly. Okay, and then the last one, got it 5. Suppose the size of a pendant are 18 millimeters long. So I'm looking at that picture that's given in problem 5, the pendant triangle. It says it's a 30, 60, 90 triangle. So this must have been the 60, so this is 30, 60, and then it's telling me the sides of the pendant are 18, so this is the pendant out here. So it's telling me the hypotenuse of the 30, 60, 90 triangle is 18, remembering that the hypotenuse is worth 2 x's, and they want to know the height of the pendant, so to the nearest 1/10 of a millimeter. So I am not doing this in simplified radical form. I'm finding the decimal. So I need this length here. So remembering back, what was that length? Well, this length was half of 2x, and this one we solved for it earlier, and it was x root 3. So I'm going to go ahead and solve for the value of x here. It's pretty easy. Divide by 2. X is going to be 9. So if I plug that in here, it's going to be 9 root 3 in simplified radical form. But if I actually calculate that out, which I'm doing right now on the calculator, root 3 times 9, and I end up at 15.5884, blah, 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 blah. And it says to round to the nearest 1/10. So at this spot, is it going to be 15.5 or 15.6? Looks like it's going to be 15.6 millimeters. Whoa, this section is awesome. It has amazing mathematical problems that should make you feel mathematically awesome. Because I can't keep saying it. They're awesome. I'm going to keep saying. Okay, anyway, love those problems. All right. Your practice problems are up on Gunnison Math, so do them and start them now so I can see if you're on the right track when I walk in. Please utilize your time, and good luck. You can do it. I believe in you.